Let's have a look at square root graphs. So square root of function x. Okay. Now obviously we can only find the square root of function x if function x is positive. So that means anything below the x-axis will just disappear. It's no longer in the domain. So here's our random curve. If we want to draw the square root of function x, so it's just that bit above that we're basically working with. Now, we're talking about the positive square root, so we know it's always going to be positive. Now, this idea, similar to what we saw with the power, but the other way around. But if the original curve, if we're talking about a number bigger than 1, then the square root of that number would go below the curve, because it's going to get smaller. Square root of a number bigger than 1 will get smaller. And similarly, if we're talking about when the function value is less than 1, then the new curve will go above the original curve. Find the square root of a number smaller than 1, the number gets bigger. So 1, yet again, becomes an important point, because the square root of 1 is 1. So we can plot those 3 points in. Square root of our horizontal asymptote, well, the horizontal asymptote is below 1, so it will get bigger, so it'll rise up. Vertical asymptote, yet again, will stay the same. It wasn't in the domain of the original function, not going to be in the domain of the new function. Now let's have a look at the derivative of this one. If I differentiate the square root of function x, eventually it would end up being the derivative over the square root of function x. So the original stationary points will again be stationary points, because if f dash x is 0, our new derivative is 0. Again, the y value may well change, but we're talking about the x value of those stationary points. But we end up with critical points at the x-intercepts. Now, it will exist, because at the x-intercept, the y value is 0, and the square root of 0 is 0, so it still exists. But we have a critical point there. So most likely going to be a vertical tangent. Might be something like a cusp. You remember those ones that come down with a V? Yeah. But basically we know the derivative is undefined at that point. Now, here's a little bit of an idea. If you know the actual function, it makes life a bit easier. Because if your original graph was, say, x to the power of 4, well, I know when I square root x to the power of 4, I get x squared. So actually, I get a turning point there at that point. So it's not always what you first think. Okay? We'll talk about y squared a bit more later, but y equals the square root of function x is a graph people like to get you to draw. But then you have y squared equals function x, which then means you're drawing plus or minus the square root. So you get a reflection in the x-axis. Y equals x cubed. Well, you can't find the square root of a negative number. So you'd end up just with a piece, something like that. X squared becomes a straight line. So that's when it now becomes a V shape. And so there's just a few other ones there. And there's 4/3, one of those cusps I was talking about. And so on. So if you know the original curve, or at least what that root looks like, then you know what the square root of it's going to look like. If it's a random curve, then sometimes we just guess based on what the original one looks like. Okay, let's have a look at my one. Well, they all look like they're just single roots. There's no inflections. The original graph didn't have any inflections there or turning points. So I think this one is going to round like a circle, if you like, have a vertical tangent at that point. Okay, now square root of naught is naught. My stationary point, the square root, well, it's bigger than 1, so it's going to become smaller. It's it's very dodgy. I tried to get it so I got a vertical tangent there. I might have exaggerated a bit. Let me get rid of the old one so you can see. So, but I've got a vertical tangent. In fact, I end up with a straight line. Sometimes not easy to draw, but the idea is being round. Some people like to actually make a note on their sketch that there's a vertical tangent here, just in case it doesn't look like it. But whoever's marking it can see you knew you're talking about a vertical tangent. Okay. Now, say if we wanted to draw y squared equals function x, instead of just y equals the square root of function x, basically be the same graph, so you draw the square root first, and then reflect it. So you can get some interesting graphs there when it's y squared equals, because essentially you've got plus or minus the square root of function x. Okay. 8G.